We are digging contamination, PCB contamination off the banks of the Kalamazoo River. Most of the contamination we find is at the toe of the bank, on the sides of the banks, and at the tops of the banks. We took, in July, we took 50 transects, or where we went across the river and we took cores out at set distances from like 20 foot up on the bank through the river to 20 foot up the bank on the other side to delineate what levels of PCBs were at what depth. And then we defined what cleanup levels were. For in the water it's 1 part per million, and on the bank it's 5 parts per million. And based on that and some modeling, estimated the depth of the contamination at every 50-foot chunk section along the bank. Now, there's old timers that live along the river here that have told me stories about how when they were kids they used to come down to the river and see it run white, green, red, whatever stock of paper that they were running, and that they would dip their bicycles, their rusty bicycles, in the water and pull it out, the bike out an hour later, and all the rust was off the bike. So this is where we started the bank removal for the PCB contamination, which mostly is on the banks and at the toe of the bank.
So this is a live stake. It's a willow, and there's about 15 different species of shrubs that grow along rivers, and the way that they propagate is that when a flood comes, they break off and they get washed downstream and they end up stuck in a sandbar somewhere, and then they grow. And so we take that principle and we use it for our own use. And so we harvest these shrubs and we cut them bottom end at an angle, top end flat, and then we're going to have the laborers drive these into the banks, and then these are going to grow roots and leaves, and by the end of next year this whole bank is going to be completely green and very densely green, and this is called bioengineering. Then the other part of this bank treatment is you can see that it has a wearing surface of root wads. So the root wads have been installed and they have trunks extending back into the banks, and the wads, the roots are sticking out into the water, and that's perfect habitat for fish, but it's also, it takes 20 to 30 years for those to wear out and rot. And so by the time that those rot away, there's going to be a forest over there.
The water's coming towards us. It's actually seeping into this bank and running underneath this structure and discharging on the other side. This whole structure sits on wooden piles, and the wooden piles are rotting and shifting, and as a result this whole spillway is collapsing. You can see here where the old wooden supports, which are all rotted away, have rotted and given way, and that this whole deck is collapsing here. This is a good part of what led us to sort of the time-critical nature of this project. The water, you would have seen a lot of erosion upstream of it, and a lot of the contaminated sediments would have flushed downstream, and it would have piled up behind the Trowbridge Dam.